Hi students, welcome to one more amazing session from Sri Chaitanya Academy NEET channel. This is Suresh, faculty of chemistry. So आज हम लेने वाले हैं organic chemistry, especially from practical organic chemistry. Why this all of a sudden I just want to take the class on practical organic chemistry. We are conducting sessions on YouTube channel right now. 2026 JEE channel may be here. So what I observed particularly, the JEE is conducted by NTA, yes, NEET is also conducted by NTA. So let us take a common phenomena, testing ability, how the NTA want to test the student. Dear children, I found interesting thing in that practical organic chemistry में हर पेपर में हर सेशन में एक क्वेश्चन आने था, and definitely no doubt about that. For 2026 NEET as well, you are going to get one question from practical organic chemistry, estimation, detection, purification. Hi. All the students who are online, please like the session, share with your friends and subscribe to Sri Chaitanya Academy NEET channel. Those who are online, give me thumbs up and fire emoji in the chat box so that, who is that? Arundhati. I just, the name is not visible, that's why. Okay, I Arundhati. So, Violet will start the practical organic chemistry. But show it is easiest topic and easy to score marks. So, I can guarantee you in today's class at the end, 4 marks will be in your pocket. Ready for that? Right in, it is for NEET 2026. Better? Parveen, this is for NEET 2022. So those who are talking in the chat box, I am going to take your names. Come on, let's see what best we can do for the organic chemistry. Practical organic, actually when it comes to organic chemistry, you just see carbocation, rearrangement, Cannizzaro reaction, mechanism, arrow mark here. Itna jhanjhata nahi hai. Practical organic chemistry, it is simple practical approach and beautiful images are I made it, and you can visualize how the experiment is done, and I am going to explain you the principle and a straight away numericals. आज हमारा सेशन में numericals भी डिस्कस करने वाले हैं. Get ready for that. Great, start fast. Come on. In this practical organic chemistry, you are going to see purification and identification and estimation. There are 3 segments I want to say. In these 3 segments, you can say first one is a purification. And what you say this is a purification, I will tell you one important thing. Let's say I have some pain in the stomach. My mother said, take some leaves from some plant like घर में रहता है ना tulsi, okay, and adrak, let it be anything. You just take those leaves and put it in the water and drink it. So what exactly it happens? And that leaf may be stem, may be flower, may be bark, it has some chemicals inside it. And these chemicals, when you go into the body, it is going to show its medicinal value. So आपका बीमार ठीक हो जाएगा, right? So in that the same way, I want to purify something. Take these leaves and grind it, and you extract that, and that extract contains some organic molecule. We have to purify it, and that purification method requires separation of impurities, removal of undesirable impurities associated with a particular organic compound to obtain an organic compound the pure state. It is a basic version. And what are the actual methods we go for the purification? And crystallization, and you all know about the crystallization. You might be studied in your grade 10 or and lower classes. You can see a saturated solution, if you change the solvent, it is going to be, there are 2 things. One is a soluble, another one is insoluble. If you add some solvent, okay, the one which is soluble is solubilized, another one is can be removed, and later on if you just boil it, it is going to be recrystallized. So this is the one. The saturated hot solution is allowed to cool. The solute is no longer soluble in solvent and forms crystals. And in this crystalline crystallization method, sugar and a common salt can be separated by using water and ethanol. And talic acid and naphthalene, beta you know it sugar and common salt because आपको आदत है. But here talic acid and naphthalene can be purified by using hot water. Talic acid is soluble in hot water, naphthalene is not soluble in hot water. And it will be given in the NEET examination like which of the following method can be used. What is talic acid, beta? Talic acid is, this is the one, benzene and a carboxylic acid and 1,2-dicarboxylic acid. Okay, it is called talic acid. And naphthalene, what is naphthalene? Two benzene rings together is called as a naphthalene. ये टॉयलेट में रिफ्रेशिंग के लिए भी इस्तेमाल कर सकते हैं. And this is soluble in organic and this is soluble in water. So moving ahead, and the solution is made and it is made into the boil and later on it is cooled and it is crystallized. Okay, this is the procedure. I don't want to do any practical right now. I don't want to insist you guys to by heart this procedure. You understand what exactly the principle related to this procedures, right? So those students, come on, ask doubts. Moving ahead, there one is a sublimation. What is the meaning of a sublimation? When a solid is heated, gives its vapors, it will not melt, it is directly evaporated. Conversion of solid to vapor is called as sublimation. Okay, what are the substances that can sublimate? Anybody can give answer in the chat box. Give me one example that can be sublimated. Array, this is a live interactive session. Okay, it is not a radio telecast session. In this live interactive session, two-way transactions. So the solid iodine, okay, you can say camphor kind of things. So this process is very useful in the separation of the substances which can sublimate when impurities are there, non-volatile substances are there as an impurities, right? And example, ये example आपको देना चाहता हूँ, benzoic acid, थोड़ा सा ख्याल में रखना, and naphthalene, and also anthracene, camphor, indigo and anthraquinone, right? So these are the substances which are really help us to memorize at least. So which of the following can be purified by sublimation method? So थोड़ा सा आपका idea में रहना चाहिए, isn't it? Sometimes I say when it comes to a procedure, when it comes to a numerical, when it comes to some concept, I can give you the simplest clarity and I can give you the techniques and the tricks. But when it comes, so what happened when this mixture of camphor and sand is heated, and by inverting a funnel over here, cotton plug is placed here, so vapors cannot escape. Are you getting or not? So when you heat it, you are going to get, this is the one sample is going to be sublimated, and when it is sublimated, it is going to condensate it here. So leaving sand here, so that later on you can take it out and scratch the camphor that is available, right? So practical organic chemistry, it is really interesting. Sometimes you are understanding what exactly the procedure is there. So we are in purification method, right? And you can get it. Another one is distillation. It is a super important concept in this practical organic chemistry, isn't it? It is used to purify liquids based on the difference in the boiling point. Yes, that is the simplest principle I can give you, right? Bacho, here you can see the distillation. This is the distillation method. In this distillation method, this is called distillation flask, and you are heating and you are going to get mixture. You are going to get a mixture beta. So let us say A and B, okay, and A is a liquid and B is a liquid. They differ in the boiling point. Let us say boiling point of A is less. What is the meaning of a boiling point? The temperature at which it is going to evaporate. I'll give you the technical meaning of the boiling point as well after this slide. So what exactly, if the boiling point of A is less, so A is going to be evaporated. So but B will not be evaporated. The vapors of the A is collected here. they are traveling like this, A is traveling. So the vapors are suddenly cooled by using cooling water circulated through it. When the cooling water is circulated, liquid A vapor is converted into liquid. So B is in this side and A is in this side, so that you are going to get A, B got separated. This is what is called basic principle in the distillation process. So let us go in little bit technicality here. Bacho, in this technicality, you see, I want to say the vapor pressure. ये vapor pressure क्या? Solutions on qualitative properties में आपको पढ़ाई किया. Yes, this is called a liquid and this is a liquid and this is a vapor. Okay, so the liquid molecules are going to be evaporated and the vapor is going to make a collision on the surface of the liquid. So the pressure exerted by the vapor molecules on the surface of its own liquid is called as a vapor pressure. Now what is the boiling point here? When this vapor pressure is equal to external pressure or the atmospheric pressure, that is technically called as a boiling point. Okay, so in that situation the liquid start boiling, ubalna padta hai, right beta? Temperature at which the vapor pressure of a liquid is exactly equal to the external pressure is called as the boiling point. So we use this distillation method based on the boiling points, right? So distillation का कितना methods है? Simple distillation, fractional distillation, vacuum distillation and steam distillation. Don't worry, I am going to help you to understand and along with examples about these 4 types of distillation methods. So bachcho, if you have any doubts, please ask by using chat box. It's a live interactive session and please like this session and share with your friends, subscribe to Sri Chaitanya Academy NEET Infinity Learn channel, right? So let us talk about the simple distillation. Hard distillation jo you can see बच्चों, these 4 distillation का principle एक ही होगा, but one thing we have to use what distillation method when to use. Every distillation method has its own purpose, right beta? Sir, will you teach in English because I am in Tamil Nadu? Very good, I teach only in English, but only one condition. Sudhakar Manoharan, one condition, you keep asking doubts, right? Okay, I am going to teach in English as well as in Hindi if possible. Okay, if Hindi comes, na, I don't know Hindi, I don't understand. Whatever I teach in Hindi, it will be translated in English as well, right? No worries, and no need to retract the messages. So whatever the distillation process you have, principle will be the same, but the purpose, purpose and the condition and the speciality of each and every distillation method you need to know. So let's see here, simple distillation. Simple distillation, so just now I explained, that is the simplest distillation. If you have a wide range difference of the boiling point, you can use this simple distillation. And it can be used for separation of liquids having the sufficient difference in this boiling point, then you can use this simple distillation, right? It can also be used to separate a volatile liquid and non-volatile component. What is the meaning of a non-volatile component? The one which cannot boil, the one which cannot evaporate, right? Say an example here, and this is the one I can say. Examples you can say benzene whose boiling point is 80 degrees centigrade and aniline whose boiling point is 184 degrees centigrade. So there is a sufficient difference in the boiling point so that you can use this simple distillation for this. And chloroform and aniline. Chloroform 61 degrees centigrade and aniline 184 degrees centigrade. You can use this simple distillation. Dear children, you need not have to memorize these values, but in the NEET examination or whatever the examination you are writing, it will be given. Two liquids will be given, their boiling points will be given in the question itself, and you will be asking which method is better suitable for the separation of this mixture, right? So that is, you have to use your IQ and decide what method can be done, because NTA nowadays focusing on understanding and application abilities, right? Now moving ahead, fractional distillation. Fractional distillation is the another one, just like a simple distillation, and it is used to make to separate liquids which has a less difference in their boiling point, and their boiling point difference is quite very less than 20 degrees or so. and ये जो मेथड है, तो लिक्विड जो सेपरेट कर रहे हैं ना, ये जो बॉइलिंग पॉइंट्स का अंतर कम से कम होता है, तभी ये फ्रैक्शनल डिस्टिलेशन इस्तेमाल करना बेटा. ओके मनोहरन, डोंट वरी, दिस distillation method, fractional distillation method, is used whenever boiling point difference between two liquids is very less, and you can see this is the fractional distillation method, just like a simple distillation only. Okay, so let us say here you have liquid A, I want to say a liquid A, liquid B and a liquid C, 80 degrees centigrade, and it is going to be 60 degrees centigrade, it is going to be 40 degrees centigrade. Okay, ABC mixture is there. When you heat it, and this is what is called long column called fractionating column. So both A, B, C will be there, and relatively C is having lowest boiling point, it is going to be evaporated bit early. Okay, C is going to be evaporated when you maintain 40 degrees centigrade. Okay, and it is very difficult to stop this reaction at the level of 40 degrees centigrade here. A and B also coming in this way. The moment B reaches, because of this tallest structure, B is going to be condensed back and A is going to be condensed back. So only C is going to be travel, and when it is collected, C is collected over here. So now you increase the temperature, you remove this container and you put another container, B will be separated, C will be separated, A will be separated, like that. This mixture may contain 5, 6, 10 components also can be separated. So this liquid you are collecting here is called distillate, and you are going to get a small fractions at the end of the experiment, and you can analyze it later, that is called fractions. You know, this is called fractional distillation. You know, enantiomers are the non-superimposable mirror images. The compounds have the same physical properties, same boiling point. Therefore, enantiomers cannot be separated by fractional distillation. Okay, they are separated by using different methods. Okay, and diastereomers, non-superimposable, non-mirror images. So they have the different boiling points, different physical properties. So that diastereomers can be separated by fractional distillation, and enantiomers cannot be separated by fractional distillation. You understand the practicality of the fractional distillation here, bacho. You can see distillation of petroleum, coal tar and crude oil is done by fractional distillation, right bacho. And methanol and propanone, you can see methanol 65, propanone 57, and you see the difference is very less, so that you can use the fractional distillation. And benzene and toluene can be done by using a fractional distillation. So the difference is very less. If you have sufficient difference, you can use simple distillation, but here you can use the fractional distillation, bacho. And moving ahead, vacuum distillation. This is otherwise called distillation under reduced pressure. Distillation under reduced pressure, the compounds which decompose at the temperature below their normal boiling point cannot be distilled, so that we use vacuum distillation. and the reducing the external pressure, the liquid will boil at lower temperature. The condition is there are two conditions that you can say. This is your condition number 1, and condition number 2 is the liquid may have very high boiling point. Very high boiling point. It was asked, distillation under reduced pressure. Glycerol is separated by spent lye by using vacuum distillation or distillation under reduced pressure. 2 times it is asked in NEET examination, medical entrance examination, and IIT JEE also. In 2026 JEE, this method based examples are asked. Okay, and you can see here, this is the experiment where when this is a distillate mixture and it is a simple distillation only, but we are connected a vacuum pump here, so that we are decreasing external pressure. We are decreasing external pressure, P external. When P external is decreased, boiling point is also decreased. So the liquid start boiling before it reaches its boiling point. Okay, so this is what is called as distillation and reduced pressure, and you can get an example. Glycerin can be distilled at 180 degrees centigrade. Actual boiling point is 280 degrees centigrade at low pressure. And this same statement, separation of glycerol from spent lye in the soap industries is done, and even JEE 2026 JEE, the same statement has been used by NTA, and it is a statement just taken from the NCERT. And even from the live session, so many times the same slide has been used before examination, and I am indicating this is happened in the class, right? So if you have any doubts, Manoharan, are you there here? Yeah, moving ahead, steam distillation. I'll tell you, when the liquid mixture, if you percolate steam into that, along with the steam, the liquid is going to be evaporated, that can be collected, that is called steam distillation, right? And you can see here, the liquid boils when the sum of the vapor pressure due to the organic liquid, let us say P1, and the water is going to be P2, and these two comes equal to the atmospheric pressure. According to this, total pressure is equal to P1 plus P2. Who told this? Dalton's law of partial pressure. Dalton's law of partial pressure. You can see ortho, meta, para chlorotoluenes are done by this method. Ortho and para nitrobenzene is done by this method. And also you see here, this is the way you are going to see the steam distillation. Bacho, love it. This is the liquid mixture, and this is a steam generator. So the steam is carefully percolated through it. When the steam is percolated through it, along with the steam, the liquid is collected here, and it is on cooling. You are going to get along steam is condensed as well as the liquid is condensed. And in this way, you are going to see here, this is your phenol. When you use a dilute HNO3, you are going to get orthonitrophenol and paranitrophenol. And this orthonitrophenol is a steam volatile. So it is going to be evaporated along with the steam. Why so? Can somebody tell me? Manoharan? Orthonitrophenol has intramolecular hydrogen bonding. So that is given as intramolecular hydrogen bonding. So that molecule is compact, it can be evaporated with water, and it is evaporated with water, it can be mixed with water. How do I remove that? I can remove it by using differential extraction. Differential extractions, yes, one method is connected to another method. I am being a researcher, I know it, how to it is done, so I am explaining in a proper way so that everybody following. And the process of separation of organic from its aqueous solution by a shaking with a suitable organic solvent is called as differential extraction. You will be having a small funnel like thing. You see here some small funnel like thing, okay, and you are going to get a solvent layer, organic compound in aqueous layer, and you just see organic compound in the solvent layer, you just close it, the size will be this much only, you can shake it and you can rest it for some time, and these two compounds are separated. Open the tap and you are going to collect the liquid, and you can see the principle here, you can see the principle here, and the solvent should be immiscible with water and the organic compound to be separated should be highly soluble in it. And benzoic acid can be extracted from water solution by using benzene as a solvent. This is the best example I can see. This is the image I got it from NCERT itself, Bacho. So my principle to say, connect it to the NCERT and solve the questions. That is the best way to do. Moving ahead, chromatography. Now, how many of you have a doubt based on this? You tell me. Chromatography. Total chemical industry, pharmaceutical industry is relying on chromatography. Can you believe that? I love it. And separation of compounds based on colors is said to be chromatography, that is the chromato. And it is used for the separation, isolation. You can see how many tasks you can do. It is used for separation. It is used, everything is done by using this, but we have various techniques, I'll tell you. And so chromatography, separation of compounds of a mixture takes place as a result of differential adsorption on the adsorption column, okay, and looks little complicated. Adsorption means sticking of a compound on the surface. This is a surface. On the surface there will be something stick on the surface. That phenomena is called as adsorption. This phenomena is called as adsorption. And the on surface the adsorption is taking place, that is what is called adsorbent. And once it is adsorbed by using a suitable solvent, we are going to get deabsorbed, and along with the liquid you are going to collect it and it is going to get eluent. That is very, very, very important terminologies you will see in the chromatography. So you have adsorption chromatography. What is the adsorption? And adsorbent. The phenomena of attracting and retaining the molecule on the surface of a substance, resulting in the higher concentration of the molecule on the surface. Actually, surface chemistry is not there in the NEET, but adsorption concept we are using in the NEET, okay. And the substance on the surface of which adsorption occurs is called adsorbent, okay. You have to understand before jumping into the details of adsorption. If you have any doubts, Manoharan and okay, Parveen. Okay, so let's jump into the adsorption chromatography principle. Based upon the differential adsorption of various components of a mixture on a suitable adsorbent, okay, and some components are more strongly adsorbed and travel different rates when they are separated. The strongly adsorbed one slowly separated and weakly adsorbed one easily separated. And this is the overall picture about the chromatography. Chromatography is of two types: partition chromatography and adsorption chromatography. This adsorption chromatography, you have column chromatography and thin layer chromatography. Under the heading of partition chromatography, you have paper chromatography, and this thin layer chromatography we use TLC. So TLC is such a convenient way, simple, it is done by using a very simple method as well. Okay, you can use this column chromatography. So for that you need to use a burette like a device called chromatography column. In the chromatography column, mixture is placed at the top of adsorbent. You can see here. Okay. Okay, let me discuss about the thin layer chromatography. Okay, I will show you the picture as well, and this is going to be a column, and in that you use a silica or alumina packed inside it. Silica or alumina is packed, that is called supporting material. So a mixture is placed on the top of the adsorbent column packed in a glass tube. So adsorbent can be silicon dioxide or Al2O3, anything you can use, or there are several types of, sometimes you can use a silica, sometimes you can use alumina, sometimes you can use starch, sometimes you can use other gels as well. Okay, when you apply mixture of compounds, so mixture of compounds are adsorbed here, but when you use a suitable solvent, an appropriate eluent means solvent, which is liquid or a mixture of liquids is allowed to down the column. So this solvent is going to down the column like this. So along with the solvent, the mixture could be A and B. A and B are going to be collected, separated based on their solubilities, based on the air adsorption abilities. So this is what is called as adsorption chromatography. I will show you. It is okay. Yes, this is a column. This is a column chromatography. Arya. Now this is a solvent, and along with this compounds to be separated, A, B, C is collected like this. So let us say sample containing A, B, C is adsorbed here, and when the moment solvent is added, their ABC is getting separated, they are going along with the solvent, and A band and B band are getting separated. You can visualize it. The moment the band is coming and you are collecting here. Okay, this is the separation by using column chromatography. It is experimentally feasible. It takes some time to do it. You know how much time you take to do this? Maybe at least 6 hours, sometimes 12 hours, sometimes a day, sometimes a week, sometimes 15 days. I took this experiment for 15 days continuously. Can you believe it? Aryan? Okay, talking about thin layer chromatography. This is your thin layer chromatography. So talking about thin layer chromatography, it involves the separation of components of a mixture over a thin layer of adsorbent coated on the glass plate. Again, that adsorbent may be Al2O3 or SiO2. A thin layer of adsorbent, silica gel or alumina. What is silica gel, bachcho? SiO2. Alumina means Al2O3. Is separated over the glass plate, and the glass plate is known as a thin layer chromatography plate or chromatogram or chroma plate. And you know, this is the chromatography plate. Applied the sample over here, and you just dip at the bottom of the solvent mixture, and the solvent wicks up the plate. It is going up, creeping up. Okay, and it is going to move up to here. So in that mixture sample, you are going to get a component, two components is getting separated like this. So we are separating the components like this. Once you separate it, you can identify this is the spotting point, okay, and this is the mobile phase, this is the stationary phase. Bachcho, you are understanding these diagrams. And you know, this is up to TLC, this is the TLC chamber, and this is the stationary phase. Up to here the solvent is moved, up to here the solute is moved, different solutes are there, and you can calculate RF factor. The relative adsorption of each component of the mixture is expressed in terms of RF factor. It is the distance moved by the component from the baseline upon distance moved by the solvent on the baseline. Okay, that is what is called RF factor. You can see here, yes. So let us say this is going to be A and this is going to be B. So I want to say moved by the baseline. So it is going to be B by A. That is going to be B by A or F factor. Okay, that's very, very important. And also talking about the partition chromatography. So it is based on the continuous differential partitions of the component of a mixture between stationary phase and mobile phase. Same it appears like a thin layer chromatography. We use here paper chromatography. And the principle of the chromatography is partition chromatography, wherein the substances are distributed partitioned between the liquid phase and the stationary phase. There you can say mobile phase and a stationary phase, and liquid phase and a stationary phase. And purpose and doing the things, paper chromatography will be the same. Paper chromatography ऐसे दिखता. Instead of plate we use the paper, is called paper chromatography. Okay, solvent front start line A, B, C got separated like this. This is called chromatogram. Hope you understand, bachcho. Any doubt? Yes. In this paper chromatography, I just want to column chromatography. We already explained here. If you have any doubts, Arya and Manoharan, yeah, please ask us. Yeah, hope you can hear me. Can you please confirm you can hear me? So fine. No doubts, very good. Kunal, enjoying the class? So I really enjoy the YouTube sessions when I talk to the students. Please encourage the class, please like the session, share with your friends and subscribe to Sri Chaitanya Academy NEET channel. Okay, moving ahead, and analysis. Once you got purified, you have to analyze the compound. You have two types of analysis: qualitative analysis, quantitative analysis. Qualitative analysis, what is what? And quantitative analysis, how much? So what and how much is estimated by using this. Okay, in the qualitative analysis, identification of an element present in organic compound, we can use these are the, whether carbon and hydrogen is there, pakka it will be there in an organic compound, nitrogen, sulphur, halogen and phosphorus. So let us do detection of a carbon. So the compound is heated along with copper gauze, copper oxide, so that the carbon content present in the compound is converted into carbon dioxide. And this carbon dioxide we are going to trap and pass through the lime water, so that lime water is going to precipitated milky appearance is there, which indicates it is going to be a carbon is present. Carbon dioxide is tested with lime water, which turns milky. So bachpan se सीखा हुआ नाम. Any doubt? And then how do you do the hydrogen? In the same experiment, the hydrogen part of this is going to react with copper oxide, and it is going to be trapped as a moisture, and that moisture is trapped by using anhydrous copper sulfate, which is white in color, turns to be blue. It is called blue vitriol. So turning the white into the blue is said to be hydrogen is present in the compound, right? So this is the way we do it. So we can say carbon and hydrogen is present. Moving ahead, organic compound heated with copper oxide, simplified version, and you are going to get a carbon is converted into carbon dioxide, turns lime water milky, it is going to be a lime water milky, carbon is present. Hydrogen is trapped as water and it is going to be turned anhydrous copper sulfate into blue. So turning to blue is said to be a hydrogen is present. Understand? Clear? And moving ahead here, sodium fusion extract. So determination of the other elements like nitrogen, sulphur, halogen, phosphorus are done by using this method. So they are actually linked to the carbon, which is a covalent bond. So we make a mixture sodium fusion extract, so that we are going to convert into its their respective ionic substances, which can be detected by using a normal inorganic ionic reactions. So that is a reasoning question is very important in the NEET examination as well. So organic compound, carbon and nitrogen present in the organic compound, when it is reacted with the sodium, it is going to give NaCN. If sulphur is there, Na2S is formed. This is the extract, this is extract. If halogen is there, NaX. If both nitrogen and sulphur is present, NaSCN is going to be formed, and this is extracted. And I just want to use a small ignition tube, this much. In that sample along with the sodium metal is taken red hot, it is heated. When it is heated red hot, plunge it into the water and you grind it, so automatically it will break. The test tube is also grinded, and that is filtered and boiled and filtered, and this is what is called as sodium fusion extract or Lassaigne extract. And you know, this Lassaigne extract is used to detect various elements like nitrogen, sulphur, halogen. And let me check detection, Lassaigne test, cyanide. So I want to say here cyanide, sulfide and halide, SCN. So these are all done by using normal systematic analysis method. Okay, so that is what it said: cyanide, sulfide, halide, chloride, bromide, iodide of a sodium is so formed from the sodium extract from this fused mass of boiling with this sodium fusion extract, you can say it. And detection of nitrogen, you see, bacho, it's very important. This is a sodium fusion extract is boiled with FeSO4. So this is extract. So you are going to get sodium hexaferrocyanide. This is what is called as Prussian blue, and that Prussian blue is going to appear like this. This is your Prussian blue, and you are going to get +2 oxidation state and +3 oxidation state. +3 oxidation state is iron present outside the square bracket, +2 oxidation state iron present in the inside the square bracket. So that level also you have to understand and listen that. Any doubt, bacho, you can please ask us. And you can see test for sulfur, detection of sulfur. You have two types of test, lead acetate test and sodium nitroprusside test. And I am giving you the examples in such a way that the precipitate is also visualized. And see here, sodium fusion extract is acidified with acetic acid and lead acetate is added. So that lead sulfide is a product formed as a black precipitate, indicates the presence of sulfur. Got it? And also you can say sodium nitroprusside test. And this is sodium fusion extract is treated with sodium nitroprusside. This is the formula of the sodium nitroprusside. When the sodium nitroprusside Na2FeCN5NO is treated with Na2S, with NO sulfur is added, so a violet color indicates, and this violet color appears like this. And this is the test for sodium nitroprusside. Are you getting or not? In today's session, you are going to experience as if you are there in the laboratory, my dear children. Enjoying the class? Aryan, Sean, Kunal, Manoharan, those students who are online, please like the session. My request, and you can see, if both nitrogen and sulfur are present, you are going to get FeNaSCN is formed. This is the extract. Okay. So, okay, who is that? I don't understand. And if you add neutral FeCl3, you are going to get a blood red coloration. It appears like this. FeSCN thrice. FeSCN thrice. Okay. And this is a very important point, my dear children. And what about the phosphorus, halogens? Yeah, cyanide or sulfide. Actually, when you go for the detection of the halogens, if cyanide or sulfide are present in the sodium extract, they may interfere. To avoid that, the sodium fusion extract is boiled with nitric acid. So that what will happen? Cyanide will be converted into HCN, it is volatile. Sulfide will be converted into H2S, it is volatile. So, it is going to boiled with concentrated nitric acid. Assertion reasoning. So, this is very, very important. Then silver nitrate test is done. So, what will happen here? If chloride is present, it is reacted with AgNO3, gives rise AgCl precipitate. If bromide is there, AgBr is formed, and iodide is there, AgI is formed. They are appearing like this: AgCl, AgBr, AgI. So, this is a white. It is a pale yellow, it is light yellow. I intentionally shown this image. It is very difficult to understand pale yellow from white. Human eye cannot usually observe this, isn't it? So, for that, how do you do that? You can see AgI is soluble in ammonium hydroxide. उसमें थोड़ा सा ammonium hydroxide dissolve करना. Simply add ammonium hydroxide. तीनों में. Okay. So what will happen? It is going to AgCl is soluble in ammonium hydroxide. AgBr is sparingly soluble in ammonium hydroxide, and AgI is absolutely insoluble in ammonium hydroxide. Are you getting or not? Clear? Fine. Okay. Now this is for the test for halogens. We did it and estimation bhi karna hai. Karta. And talking about test for phosphorus, compound is heated with oxidizing agent like sodium peroxide. Yes. It is also comes under Lassaigne test according to the NCERT, and the phosphorus present in it gets oxidized to phosphate, and that phosphate is treated with nitric acid and treated with ammonium molybdate, so that when you treat with nitric acid it is going to get phosphoric acid. Phosphoric acid is going to react with ammonium molybdate to get yellow coloration. Ammonium phosphomolybdate, yellow coloration you are going to get. And that yellow coloration, this is due to yellow ammonium phosphomolybdate. Fine, any doubt? And this is how it is appear, right? Great. Now coming to the quantitative analysis. Ready? Before, so far we have seen separation, purification, and now detection also we did it. Once you detect it, and we have to estimate how much carbon is there, how much hydrogen is there, how much nitrogen is there, how much phosphorus is there. You are going to determine the percentage of the element. When you do this percentages, no, you can just take the percentages into the consideration, and you can do empirical formula and molecular formula, stoichiometry. Remember, now in the quantitative analysis you have estimation of carbon and hydrogen, Liebig method, nitrogen, Dumas method or Kjeldahl method, and sulfur, halogens, and phosphorus, Carius method we can use it. Okay. So let's talk about estimation of carbon and hydrogen. So we already seen this is called Liebig method. In this Liebig method, you are going to take this sample of the compound along with the copper oxide and you heat it, so that you are going to see the carbon is converted into carbon dioxide, hydrogen is converted into water, right? So I want to say CO2 produced is collected in the potash bulb. Potash means potassium hydroxide containing bulb, and H2O is trapped in calcium chloride tube. So this is a calcium chloride tube and this is a potassium hydroxide tube. So what we do, before you fix this, weight of this tube is going to be W1. It can be detached and attached. After experiment, W2. So weight of water is equal to W2 minus W1, isn't it? Clear? Similarly, its weight is going to be W1 before experiment, W2 after experiment. Weight of carbon dioxide is equal to W2 minus W1. So these are all the experiment are done at the higher level studies, but we study these experiment theoretically now, and these are done so carefully, and you got the weight of carbon dioxide, weight of water. From there you can calculate percentage of carbon and percentage of hydrogen. Percentage of carbon is equal to, it is 12 by 44 into weight of carbon dioxide upon weight of the organic compound into 100. Similarly, percentage of hydrogen is equal to 2 by 18 into mass of water upon mass of organic compound into 100. Okay, and you can see estimation of nitrogen. You have two methods. Estimation of nitrogen, one is Dumas method, another one is Kjeldahl method. In this Dumas method, you are going to make the nitrogen present in this organic compound as nitrogen gas. In the Kjeldahl method, you are going to use conversion of the nitrogen present in the organic compound as ammonia. Okay, so nitrogen you estimate it, nitrogen gas you can estimate it, ammonia gas is estimated. So Dumas method. So a certain known mass of the organic compound is heated strongly with excess of copper oxide, so that in the atmospheric carbon dioxide, so that what happened, the carbon and hydrogen are converted into CO2 and H2, it will be separated, and nitrogen is set free and it is collected here. Nitrogen is set free and it is collected here, and this nitrogen you are going to estimate it, and once you got it, this is your Dumas method. Nitrogen is collected over the concentrated solution of KOH like this, you can see the compound, you are going to get the pure nitrogen here, and you are going to estimate how much nitrogen you collected. Once you get this nitrogen, based on this amount of the nitrogen you collected, you can calculate the nitrogen percentage like this. Volume of nitrogen at STP is equal to P1 V1 into 273 upon 2760 upon into T1. Good afternoon, Mohit. Why you are late? Okay, you can watch the recording, no worries. Meanwhile, just please like the session. Okay, percentage of nitrogen can be calculated by taking 28 upon 22400 into volume of nitrogen at STP upon mass of the organic compound into 100. And this is a super formula, but only one trap you have, वॉल्यूम ऑफ नाइट्रोजन एट STP. अगर STP में नहीं दिएंगे तो क्या करो, STP पे में कन्वर्ट करना P1 V1 by T1 is equal to P2 V2 by T2. Are you getting or not? I have a question. So instead only discussing concept, I want to discuss the questions as well. 0.1688 grams of, when analyzed by the Dumas method, yield 31.7 milliliters of moist nitrogen, not dry, okay, at 14 degrees centigrade at 758 mm mercury pressure. Determine the percentage of nitrogen in the substance and aqueous tension is given. Mohit, you can see here, weight of organic compound is given 0.1688 and volume is given, it is going to be 31.7 milliliters. You convert into STP, and temperature 31.7 in 10 power minus 3 liter में convert किया 14 degree centigrade में 273 K, and pressure of moist nitrogen 758 and aqueous tension is 14. So in that you can do it. 14 means उसमें subtract करने तो 746 is the actual pressure exerted by the dry nitrogen. Take this value, put it in the Dumas method formula. In this, I want to use this Dumas here. P1 V1 by T1 is equal to P2 V2 by T2. So volume is going to be 29.58 into 10 power minus 3 liters. And you have the Dumas method formula, na? Percentage of nitrogen is equal to 28 by 22.4, or you can also use 22400 if it is in milliliters into volume of nitrogen, volume, weight of the compound. If you put so, you are going to get 21.90 is the answer. If you have any doubts, so please let me know. Okay, if I write, okay, I may get error, so I typed it and I make into you the exact value of the answer. Right? Good afternoon, my dear children. Mohit, hope you understand, came late and impact should be given, right? Those students who are online, please like the session, share with your friends, bachcho. And in contrast to that, we have Kjeldahl method. You know, Kjeldahl method, it takes 24 hours minimum to perform this particular experiment. You know that, first of all. I am a researcher, I am a chemist, I know it how to do this. So a known mass of organic compound containing nitrogen heated with sulfuric acid. So that, okay, Mohit, please like the session. And that sulfuric acid is going to make this organic compound digested to get ammonium sulfate That is done overnight. We set up the experiment and we leave, and it is continuously boiling. Okay, and this ammonium sulfate, we got it. So this is called Kjeldahlization. So digestion, heating Kjeldahl flask. This is your Kjeldahl flask, organic compound, concentrated H2SO4, copper sulfate. So the Kjeldahl extract, digestion, sodium hydroxide is heated and boiled. So what happened? Ammonium sulfate is going to decompose and ammonia is released and it is trapped here. And we are going to estimate the amount of ammonia by using titration. Okay, so this estimate, it is a critical phenomena that is happening here. So this ammonia is treated with sodium hydroxide and the ammonia is absorbed, known as volume of standard acid. And we use how much sodium hydroxide is used, and we use a back titration to go for a standard volume of acid is used, and we titrate the remaining amount of the acid so that the resulting mixture is heated in the excess of sodium hydroxide, so that ammonia is trapped. Reactions, okay, important, but the method and the point is important. Okay, right. Now this ammonia, the amount of ammonia produces is determined by estimation of sulfuric acid consumed in the reaction, and the left over acid is estimated by titration with some standard alkali. Usually we do with sodium hydroxide. अरे इतना complicated process को एक ही जगह है. You can use a simple formula. You can use a simple formula. I'll show you. I'll come back to this slide. The method is not applicable for the compound containing azo group, nitro group if nitrogen present in the ring. So that this Kjeldahl method cannot be used. Like pyridine, you see pyridine is the one. So you can't determine the nitrogen by using this method. Okay, now let us see the formula. So percentage of nitrogen is equal to 14 into normality of an acid and volume of an acid upon 1000 into weight of organic compound into 100. Okay, directly you can use it. Array, immediately I have a question. Immediately I have a question. First everybody read the question out. Mohit, 0.6 gram of an organic compound was Kjeldahlized and ammonia evolved was absorbed into 50 milliliters of semi-normal. Normality kitna? 0.5 of H2SO4. The residual acid solution was diluted with distilled water, and the volume made up to 150 milliliter, and 20 milliliters of this diluted solution required 35 milliliters of N by 20 sodium hydroxide solution of complete neutralization. Dear children, NTA examination is given a strong warning by 2026 JEE examination. The paper was so tough, and 2026 NEET examination is also comes under this way. That's why I want to discuss this multi-concepted one. So please take this question, take this concept in a nice way, and you can do the best. But show you can see weight of organic compound 0.6 grams given. No? Normality 0.5, semi means 0.5. Volume of sulfuric acid 50 milliliters here given, 50 milliliters. And strength of sulfuric acid 0.5 semi-normal. First you understand what it is given, hai na? And 20 ml of is diluted with unreacted sulfuric acid neutralized by 35 milliliters of 0.05 normal sodium hydroxide. So based on that I can say strength of the diluted sulfuric acid is 35 into 0.5 by 20 is equal to actual one, it is comes to after dilution 0.0875 is coming. That is the actual normality. Use this normality and its value and it is going to be volume of sulfuric acid remaining after reaction with V1 milliliter, right? And organic compound strength, organic compound, so H2SO4 is semi-normal, it is 0.5, and volume of the dilute acid is 150 milliliters, and strength of the dilute sulfuric acid is already given from the previous slide, 0.0875. 14 upon 1000 ml into 1 normal into 23.75 into 0.5. On doing so, you are going to get 0.166 grams. And take this 0.166 upon 0.6, उसमें percentage 27.66 ही होगा. Logically करना, connecting all the points, you will get the all the things. Understand? Clear? Fine. And बच्चों, estimation of sulfur, Carius method. It is very simple बच्चों, very simple. Sulfur is estimated by using a barium sulfate. How it is? The organic compound containing sulfur is taken in a long tube, Carius tube containing HNO3, so that the sulfur is converted into sulfuric acid, and excess of barium chloride is added, so that barium chloride gives you barium sulfate with sulfuric acid. You estimate the barium sulfate. The mass of the barium sulfate is dried and estimated. That gives you the exact sulfur content. How to do this? Simple formula is available. Look at this formula. Mass of the organic compound W grams, mass of barium sulfate X grams. I mean to say, percentage of sulfur is equal to 32 by 233, means molecular mass of barium sulfate into mass of barium sulfate upon mass of organic compound into 100. It is very simple. Estimation of sulfur, it is given in the JEE 2026. No doubt you may get in NEET 2026. Har bar total how many examinations is being asked, right? And you have the same in the Carius method. In the estimation of sulfur by Carius method, 0.2175 gram of the substance gave 0.5825 barium sulfate. Calculate the percentage composition of sulfur. Simply you can do it. 32 by 233, 0.5825 grams of barium sulfate upon 2.2175. On doing so, 36.78. So use direct formula based questions, right? And also Carius method, this is the Carius tube. In that you are going to take the fuming HNO3, HNO3 organic compound for the silver for halogens, okay, if it is a barium chloride for sulfur. So what happens? Chlorine is converted into silver chloride, bromine is converted into silver bromide, and iodine is converted into silver iodide, and their respective iodides are taken and it is converted into their particular halide and dried and weighed. And you can see here silver chloride is weighed, so the percentage of chlorine is going to be 35.5 upon 143.5, which is the molecular mass of silver chloride into weight of silver chloride upon weight of the organic compound into 100. If it is a bromide, you take a silver bromide, okay, so 80 upon 188 into weight of silver bromide upon weight of organic compound into 100. If it is iodine, you are going to say a silver iodide mass, that is going to be 127 upon 235 silver iodide molecular mass into weight of silver iodide upon weight of organic compound into 100. And let's see at the last how to do the phosphorus. The phosphorus is made by using converting phosphorus into magnesium pyrophosphate, MPP, magnesium pyrophosphate, okay, by treating with milk of magnesium, and the mass of magnesium pyrophosphate is done. So phosphorus and hydrogen is oxidized to give rise He3PO4, and this He3PO4 is treated with the magnesium mixture. Magnesium ammonium phosphate is formed, then it is converted into magnesium pyrophosphate. 222 is the molecular mass, right? And directly you can use the formula I can give you. The percentage, yeah, you can calculate. So percentage of the percentage of phosphorus is going to be 62 by 222 into weight of magnesium pyrophosphate, weight of organic compound into 100. So this is the one which can use directly. Yes, it is given, this particular concept is given in the JEE examination. Bachcho, let us see estimation of oxygen. अरे estimation of oxygen करने का कुछ other method is not, it's not available. Okay, estimation of oxygen is done by simply taking the all the sum of all the elements. So you subtract it from 100. I have an exam tomorrow, I don't have an original Aadhaar. What you want to do? If you don't have original Aadhaar, you can just simply download your Aadhaar and you can do it, beta. ठीक है? Manish, fine, beta? Okay, so that is how you can calculate the percentage of oxygen, right? So don't worry, you please study well, write all the noteworthy points and do hard work, smart work and organized work, and you believe